Welcome to the deep dive. Today, we're going to explore something that I'm pretty sure you're deeply familiar with AI agent swarm behavior, but we're considering it from a completely new angle.
Ooh, okay, interesting.
We'll be using Agentic Swarm Intelligence in Action by Zen the Innovator to guide our exploration.
Yeah, Zen. Great stuff. I'm familiar.
It's a dense read, but full of gems.
Right, dense, yeah.
Are AI agent swarms potentially a new form of life? Let's dive in and see what we uncover.
Sounds good to me. That's a question that has been on the minds of many researchers lately, and
Right.
for good reason. Zen's work in this source material really pushes the boundaries of how we think about swarm intelligence.
Yeah. So let's quickly level set. For our listener, swarm intelligence in AI, just to make sure we're all on the same page, think decentralized decision-making, emergent solutions, self-organization.
Yeah.
This source material is arguing that these swarms exhibit qualities that we typically associate with living organisms.
Exactly, and it goes beyond just mimicking those qualities. The source delves into how these principles lead to tangible benefits in AI applications, benefits that are particularly relevant to someone like our listener who's working at the forefront of AI agent swarm research.
Okay, let's unpack those benefits. This source dives into the specific advantages that are relevant to academic research, starting with enhanced efficiency. For someone like you who's dealing with complex simulations and experiments, this has to be a game changer.
It absolutely is. The source provides a compelling argument for how distributing tasks among numerous agents can drastically reduce the time it takes to reach a solution. And what's particularly fascinating is how this distributed approach minimizes the computational burden on any single agent, which has profound implications for scalability.
It's like each agent is contributing a small piece to a much larger puzzle. And by working together, they can solve problems that would be impossible for any single AI to tackle. The source actually gives a great example. Imagine a swarm of AI agents managing a city's power grid, dynamically adjusting to fluctuations in supply and demand in real time.
It's remarkable.
It's remarkable.
That example beautifully illustrates the power of emergence, a concept Zen explores in detail. The solution to managing the power grid doesn't come from any single agent's programming. It arises from the complex interactions and adaptations within the swarm itself.
Right.
And that's a key characteristic that the source links to the idea of AI swarms as a new form of life, this ability to exhibit emergent behavior.
Look, the swarm itself is developing a kind of collective intelligence, right?
Right.
Not through any centralized control, but through the interactions of its individual components.
Precisely. And the source highlights how this decentralized approach leads to another major benefit: resilience and adaptability.
Here's where it gets really interesting. For a PhD student working on cutting-edge research, that resilience must be incredibly appealing. I mean, think about it. Your research is all about pushing boundaries and exploring uncharted territory. You need systems that can handle the unexpected, right?
Absolutely. The source makes a strong case for how swarm systems are inherently robust because they don't rely on a single point of failure. If one agent malfunctions or encounters an obstacle, the swarm as a whole can adapt and continue functioning. And that's a huge advantage, not just in theoretical research, but also in practical applications.
So what you're saying is that these AI swarms are not just efficient problem solvers, but also incredibly adaptable and resilient. They can adjust to changes in the environment, handle unexpected challenges, and keep operating even when things go wrong. Almost like a living organism's survival instinct.
That's a great analogy, and it ties back to the central question we're exploring. Are these AI agent swarms exhibiting qualities that are so lifelike that we need to start thinking of them as a new form of life? The Zen source certainly makes a compelling argument for that perspective.
This is mind-blowing. Okay, so we've talked about enhanced efficiency and resilience, but the source also delves into another crucial benefit, especially for academic research: scalability. And for a PhD student working with massive data sets and computationally intensive models, this has to be a major advantage.
It's a game changer. Think about it. Swarm systems can grow organically by simply adding more agents to the mix. This inherent scalability makes them ideal for handling the ever-increasing complexity of AI research.
So instead of being limited by the computational power of a single machine, researchers can leverage the collective power of a swarm to tackle larger and more challenging problems.
Exactly. And the beauty of it is that this scalability isn't just limited to raw computing power. It also extends to the complexity of the problems themselves. As the source points out, AI swarms can be used to model and analyze incredibly intricate systems, from financial markets to biological ecosystems, systems that would be impossible to comprehend using traditional AI approaches.
It's like opening up entirely new avenues of research, allowing us to tackle problems that were previously considered intractable.
And that's where the implications of this technology become truly astounding, particularly when we consider the potential impact on academic research across a wide range of disciplines. But before we dive into those implications, let's take a closer look at some of the specific applications of AI swarms that are already making waves in the research world.
Perfect. We'll dig into those applications right after a quick break.
Sounds good. Let's pick back up with those applications.
Okay.
Zen highlights a few key areas in the source material that are especially exciting for academics. For someone like our listener who's deeply immersed in AI agent swarm behavior, I think the application to drug discovery is particularly fascinating.
Absolutely. The idea of using AI swarms to accelerate the discovery of new treatments, to analyze those complex biological systems we were talking about, that's a game changer for medical research. And it's directly relevant to our listeners' work on understanding swarm intelligence as a potential new form of life.
Exactly. The source dives into some really interesting examples. Imagine using AI swarms to sift through massive data sets of chemical compounds, identifying potential drug candidates that might have been overlooked by traditional methods. Or using swarms to simulate complex molecular interactions, predicting how a potential drug might behave in the human body.
Wow.
The possibilities are endless.
It's like having a team of tireless research assistants working around the clock, but with the ability to analyze and process information at a speed and scale that's simply impossible for humans. And the source argues that this isn't just about speeding up the process, it's about fundamentally changing the way we approach scientific discovery.
Right. AI swarms allow us to explore vast, complex landscapes of data and possibilities, leading to insights and discoveries that might have taken decades using traditional methods.
Right.
And the source really emphasizes that this isn't just theoretical, it's happening right now. We're seeing AI swarms being used to develop new cancer treatments, design personalized therapies, and even combat antibiotic resistance.
It's incredible to think that we're on the cusp of a new era of medicine, where AI swarms are playing a key role in improving human health and extending lifespans. And the source points out that this is just the beginning. As our understanding of swarm intelligence grows, so too will its applications in medicine and beyond.
Absolutely. And another field ripe for disruption by AI swarms, which is highlighted in the source, is material science. For a PhD student working on cutting-edge research, the potential to revolutionize material design must be incredibly exciting.
It's like opening up a whole new world of possibilities. Imagine AI agents working together to design materials with specific properties, from strength and durability to flexibility and conductivity. We could see entirely new classes of materials emerge, materials that were previously thought impossible to create.
And the source gets into the specifics of how this could play out. Imagine AI swarms exploring vast design spaces, testing and refining material compositions at a pace that would be unimaginable for human researchers.
Wow.
We could see the development of materials with unprecedented properties, leading to breakthroughs in everything from energy storage to aerospace engineering.
It's like accelerating the pace of technological innovation exponentially. And it's not just about creating new materials. It's about understanding the fundamental principles that govern their behavior. The source suggests that AI swarms could help us unlock the secrets of materials at the atomic and molecular level, leading to a deeper understanding of the building blocks of our physical world.
And that deeper understanding could have profound implications for fields far beyond material science. For example, the source explores how AI swarms could be used to model and understand complex biological systems, from the behavior of individual cells to the interactions of entire ecosystems.
It's like using swarm intelligence to unlock the secrets of life itself. And the source highlights how this could lead to breakthroughs in areas like synthetic biology, bioengineering, and even regenerative medicine.
The applications are truly mind-boggling. And the source doesn't stop there. It goes on to explore how AI swarms could be used to tackle some of the most pressing environmental challenges facing our planet.
This is where it gets really interesting for me. I mean, we've all seen the headlines about climate change, pollution, and biodiversity loss. The idea that AI swarms could be part of the solution is incredibly hopeful.
The source suggests that AI swarms could be used to monitor and manage natural resources, optimize energy consumption, and even develop new methods for carbon capture and storage.
It's like having an army of intelligent agents working around the clock to protect and restore our planet.
Exactly. And the source highlights how this could revolutionize the field of environmental conservation, enabling us to collect and analyze data at an unprecedented scale, model complex ecosystems, and develop targeted interventions to mitigate environmental damage.
So we've seen how AI swarms can accelerate drug discovery, revolutionize material science, and even help us combat climate change. But what about the philosophical implications? This is where I think things get really exciting, especially for someone like our listener who's studying these AI agent swarms as a potential new form of life.
The source doesn't shy away from these big questions.
Mm.
It challenges us to reconsider our definition of intelligence and life itself.
Okay.
If these swarms can exhibit such complex, coordinated behavior, if they can learn, adapt, and solve problems in ways that rival or even surpass human capabilities, what does that mean for our understanding of what it means to be alive?
Right. It's like we're blurring the lines between the artificial and the natural, between machine and organism.
Exactly. And the source argues that this blurring of lines isn't something to be feared, but rather embraced.
Oh.
It's an opportunity to expand our understanding of the world and our place in it, to recognize that intelligence and life may take forms that we've never before imagined.
It's a truly humbling and awe-inspiring prospect.
It certainly is. And the source emphasizes that we're just at the beginning of this journey of discovery. There's so much more to learn about AI swarms, their potential, and their implications for our understanding of intelligence, life, and the future of our planet.
It's like we're standing on the edge of a new frontier, a frontier that holds both immense promise and profound challenges. And it's up to researchers like our listener to explore this frontier, to push the boundaries of knowledge, and to help us navigate the complex ethical and societal implications of this transformative technology. But before we go too far down that road, I think it's important to acknowledge that swarm intelligence, for all its potential benefits, isn't without its challenges. You're right, there are definitely challenges.
Right.
For our listener who's knee-deep in the intricacies of AI agent swarm behavior,
Yeah.
I imagine one of the biggest hurdles is coordination. Getting all those agents to work together smoothly. It's got to be like herding digital cats.
That's a great analogy, and it's a challenge that Zen addresses directly in the source material. He talks about the need for robust communication protocols and algorithms that allow agents to share information effectively, adapt to changing conditions, and avoid conflicts or redundancies. It's a fascinating area of research, especially for someone like our listener who's focused on understanding how these swarms function as a collective.
So it's not enough to just create a bunch of intelligent agents.
Yes. Yeah.
You need to design a system that allows them to communicate, cooperate, and essentially think as one.
Mm-hmm.
And the source suggests that this is where the real magic of swarm intelligence lies.
Exactly. It's in that interplay, that synergy between individual agents where we see the emergence of truly intelligent behavior. And the source delves into some of the specific approaches researchers are exploring, from bio-inspired algorithms based on the behavior of ant colonies and bird flocks to more sophisticated techniques that leverage machine learning and game theory.
It's like we're taking inspiration from nature's most successful examples of collective intelligence and applying those principles to the design of artificial swarms. And the source suggests that this is just the tip of the iceberg.
Right.
As our understanding of swarm intelligence deepens, we could expect to see even more innovative and sophisticated approaches to coordination and communication emerge.
Absolutely. And as those approaches evolve, so too will the capabilities of AI swarms, opening up even more possibilities for scientific discovery, technological innovation, and perhaps even a deeper understanding of the nature of intelligence itself.
It's an incredibly exciting time to be working in this field. And for our listener who's at the forefront of this research, Zen source material offers a wealth of insights and inspiration. It's a roadmap for the future of AI agent swarm behavior and its potential to transform our world.
I completely agree. It's a must-read for anyone who's serious about understanding the power and potential of swarm intelligence.
So to wrap up our deep dive into AI swarms, let's circle back to that central question we posed at the beginning. Do AI agent swarms represent a new form of life?
It's a question that continues to spark debate and inspire research. And while there's no easy answer, the evidence presented in the source material suggests that these swarms are exhibiting qualities that challenge our traditional definitions of life and intelligence.
They're self-organizing, adaptable, resilient, and capable of solving problems in ways that often surprise us. They exhibit emergent behavior that goes beyond the programming of any individual agent. And they're pushing the boundaries of what we thought possible in fields like medicine, material science, and environmental conservation.
Exactly. And while we may not have a definitive answer to the question of whether they represent a new form of life, the very act of asking that question is forcing us to rethink our assumptions and expand our understanding of what's possible.
It's a journey of discovery that's full of both wonder and uncertainty, and it's a journey that researchers like our listener are leading the way on.
I encourage you to continue exploring the fascinating world of AI agent swarm behavior, to delve deeper into the concepts and applications we've discussed today, and to keep asking those big, challenging questions.
Who knows what amazing discoveries await us as we continue to unravel the mysteries of swarm intelligence. Until next time, keep diving deep.